Hi guys, I have a little speaker here. This is a M-Audio something, we'll see on the back actually. So yeah, BX8 M-Audio. The guy who this belongs to is actually a DJ and also pool lifeguard at one of the hotels, so he does the entertainment, or at least part of that team, and some lifeguarding. Okay, he uses this at home actually, so this is attached to his computer. I'm not sure if he has one or two of these, and he uses this when he's putting music mixes together, and he says he has no sound. I'm not sure if he means it's dead or whether it powers on but there's no audio. So let's connect this to just some music first and let's see what it actually does. So you see the light bulb over there. Not only will this stop this like going bang if it is inclined to, but we'll also see if any power gets into this. So let's have a look. Bright dim, there was a loud pop, but that was when I switched it off. Yeah, let's switch that out. Let's go again. No pop. Okay, no noise at all this time. I don't know what caused a pop. I'm sure it came from the speaker itself. Okay, let's just put some audio in, see if we get anything coming out of this in the way of audio. Okay, that's what we get coming out of it, farting noises. Okay, so it makes farting noises, that's what it does. Okay, so one bag of farts speaker. I think we'd better open this up and have a look inside to see what's going on. Okay, so we have apparently 80 watt low frequency amp and 70 watt high frequency amp. 80 watt woofer, 70 watt tweeter. Okay, that's what we have. This is what's inside it. So those 150 watts are coming through here. That's transformer. So the transformer dong gang, okay, dong gang, has 25 volt output, well 25.5 times 2. Okay, so there's two outputs at 25.5, 2.3 amp. So just out of interest, 225.5 is 51. Times 2.3 is, well, times 2 is 102, and a third of 50 is about 16, 17, something like that. Yeah, so about 120 watts that can actually provide, actually. So yeah, we get 150 watts output from 120 watts maximum power from the transformer. That's interesting. Yeah, they do magic, these Chinese. 117.3 watts I've just calculated actually, so a bit less than 120, but anyway, that's magic. Yeah. So it's a magic amplifier, and that's assuming 100% efficiency, and the amplifier is something like probably, well, it's not a class D, I don't think, so it's probably at best 50% efficiency. So the actual maximum wattage out of this must be about 60. Yeah. Shared between the two. Okay, so that's what's inside it. This has a linear power supply then, connections to the two speakers. I'm just having a look at the PCB here. Hard to spot anything obvious there because it's, well, kind of mounted on this quite hefty heatsink, I will say actually. So it looks like we have two amplifier ICs, in fact, rather than like output transistors. It'd be very interesting to see what they are as well, actually. The question then is, why did it fart? Yeah, I mean, that looks maybe that this capacitor has been leaking. Okay. I think I'll unscrew this board from the actual front panel if it's easy to do, and then maybe get a better look at what's going on with this. Okay, I've got this off. I had a lot of trouble with the ground lead, which was this one. You see, I ended up cutting it and stripping it, and I've done that from both sides. The little thing it was attached to down there is captive, and then I've tried getting a socket and a wrench on that, but it's just not helping me. Basically the whole thing's turning round, and the other end is like a screw where somebody effectively has filed 2 chunks off it so you can't unscrew it. But anyway, we can cut that, we can solder it back, and we can put some heat shrink on, so I don't see why they bothered, to be quite honest, and there isn't to be. So I guess we could check to see if we have the correct voltage here. That's probably the first thing we should do on these capacitors. I'm very suspicious of that one. Maybe we should just then unsolder those capacitors and have a look. I can see one of them is here. Okay, where's the other one? Yeah, there. These two are connected together here and here, so this is going to be, you would assume, ground, but then that seems to connect to there. Weird. Well, you'd expect that to read open, or just see the capacitors charging actually. Yeah, charging the other way. Yeah, that doesn't go to there. It just looks like it does. How strange. Oh, we can see now it doesn't go to there. It didn't make any sense that it did, to be honest. Right, let's power this up and let's see what voltages we can see on these capacitors. This is the negative end of one and the positive end of the other, so these are actually connected together here. Okay, so we can measure with the black lead to here, and we should see a positive and a negative supply, which should be the same as each other. Let's see. So power on. From here, minus 37. Plus 37, just about. So they're very similar. Just switch off again. That's already discharged to 0. That's already discharged to 0. Okay. So they discharge very fast, actually. No, I tell you why. That is a negative still on there. Oh, and that one is discharged faster than the other one. We can see that. As I've seen before, that is not necessarily the sign of a problem. And the one that discharged the faster is the one that appears to be the good one anyway. Okay. Here is one of the amplifier chips, TDA7294. I can't easily see the other one because of all the glue down there. Yeah, I can't see the numbers on that one, but it looks very similar. I wouldn't be surprised if they're the same, which is interesting, seeing as the two outputs for the speakers have different wattages apparently. Yeah, okay. Let's look up the datasheet for that one. TDA7294. And there it is. So 100 volt, 100 watt DMOS audio amplifier with mute standby. It looks like this then could run on a plus and minus 50 volt supply. We have plus and minus 37. So obviously it will produce less wattage at a lower supply voltage. Yeah, there. Supply plus and minus 50 is the maximum. Okay. Here is a typical application, so we can pretty much see how this works. And I suspect we actually have 2 of these. So I think I'll have a look at that capacitor. Although I'm seeing the same voltage in both, it looks rather suspect to me. That'll be one of these 2 capacitors we see here, C6, C8, I'm guessing. And if the capacitors test okay, then let's see if we can extend the wire so we can connect the speakers back up to this while we have it on the bench. and see what happens. Okay, it's out. I basically cut through the glue as best I could, but obviously there were wires down here which made it not so easy. Then I used solder braid to remove this solder, put some fresh solder first, solder braid came off, and then once I got these desolder, I effectively just forced it backwards and forwards so the glue gave up. The glue is fairly soft actually, so it wasn't too difficult to do that. You see, it's quite like a rubbery silicone type adhesive. Okay, 6,863 volt capacitor. Let's see how this one actually reads. Well, it reads okay, but interestingly, I can't actually get a stable reading from it. Bit unusual that. Let's see if I have any more like this. Well, I don't have. I really don't like the look of this at all. I'll unsolder the other one and let's see how that reads. Okay, so what does this one look like? Well, kind of the same. It's kind of wandering around a little bit. Maybe this is just the meter there. Again, on the other one, the bad one. Same sort of thing. I could measure the ESR, but bear in mind these are not low ESR capacitors. But it might tell us something. Well, that one reads 0.376, you can see it. That one, no, it's going back to the same. It actually reads a bit lower on that one. That's the one that looks bad. Okay, so there's nothing conclusive there as to what this might even be on here. Did it come out of the capacitor? Is it just some sort of glue that's been poured over it? Maybe that's exactly what it is. Okay, so nothing conclusive there. So we'll put these back in. Then we'll power this up and we'll have a look to see what we have coming out of the amplifier for a given input. What I can see though is enough to tell me these two chips are the same, almost certainly. And actually, I think I've spotted what's wrong with this. Look. That ain't gonna help. Yeah, that is not gonna help. So there is something else to replace as well as fitting those capacitors back on. I've removed the volume pot. It's in a very sorry state. This didn't actually happen like due to me unsoldering it. You can see an actual fact that is broken. The bodywork was broken on it. Okay, it's actually unsoldered very easily. You can see there it came out cleanly, so I used the vacuum desoldering tool to unsolder this. No harm done there. So yeah, the actual pot was physically broken. The first problem I think with this is A20K, which is going to be logarithmic and hard to find, at least in like the more normal sized volume controls. I'm not sure about these small ones. Let's have a look to see what I have. And I don't have one like this. This is probably the closest I have, but you can see that the mounting isn't the same. It's horizontal, whereas this is like a vertical mounting one, so that's not going to help. Plus it doesn't have the threaded shaft here. Okay, so I'll now have to find one of these or some of these to order, but in the meantime I'm just going to connect a normal, if you like, potentiometer to the board and power this up and see if it actually works. Even in the larger or standard size potentiometers, I don't have any A20K. I have B20K, single gang, dual gang, but not the A, not the logarithmic. So these are linear. So if I fitted one of these, what we would find is that the volume control doesn't work properly. Rather than getting like a smooth variation in voltage from one end to the other, all the adjustment would effectively just be at one end. Okay, almost like all or nothing. So even if I find one of these as a B20K, it's not going to work properly. But what I'm going to do is I'm going to solder some wires on here, attach it to the little amplifier, and we can see A, if it works, and see what effect fitting the linear one actually has on it, if it does work. And if we know everything else is okay, then it comes down to sourcing these, okay? And here we have it. So I've just got this kind of like the exploded view, as they call this, on the bench, okay? This is the potentiometer that's just wired on. I've connected to the speakers from the amplifier, so we can kind of get to this. Let's power this up and let's see what it does now. Power on. Any music? No. So it's not the potentiometer, okay? But that needs changing. So let's have a look to see what's actually wrong with this. We can see that the audio comes in here. We have a number of op amps. So probably this area of the circuit will divide the signal into the bass and the high frequencies and send them to the appropriate amp. The best place probably to start is to have a look on the inputs to these amplifier modules. Now, they will come through a resistor, and because these are effectively op amps, just high powered ones, we probably won't see a signal directly on the input. But if we find the resistor the signal is coming through, we can check there. The idea is that if we look on the input and the output of the amplifier module, we can determine, I would imagine, whether the problem is before the amplifier or something with the amplifier module itself. So let's have a look at the datasheet again and let's figure out where the signal comes in, and then we can check. Okay, here's the typical application. So we can see that the input is on pin 3, the audio. This effectively is the AC generator, if you like. If you weren't sure what that is, you could always just look for a amplifier circuit diagram and you'll see the input is on pin 3. Okay. The other input, the inverted input, this is your feedback. So you can see from the output of the amplifier, feedback to the input. And we also have this resistor to ground. So the ratio of these two resistors will set the gain of the amplifier. The capacitor here, which is part of that feedback network, is to alter the gain across the frequency band, okay? So at higher frequencies, this has a lower resistance, so there's less gain, basically. It's probably also there to stop the amplifier oscillating at high frequencies, but I'm no amplifier expert. I basically know what it's there for, and I know how to test if it's good or bad. So we can see the input there. We checked previously, and we know we have supply on those large capacitors, but there's something else we didn't check, and I think we should check it before we start looking at the inputs we have here. And what we didn't check is the power to these op amps. Okay, these are op amps, probably dual ones. I haven't looked up the data sheet. We can go and have a look. The power for these, I would imagine, is going to be plus and minus 15 or something like that. And I would say that's what these two devices are doing here. Although it's difficult to see down there, I would say this is a positive and negative voltage regulator. So if the plus and minus, let's say 15, is wrong or one of the rails is missing, that would probably cause some problems like this as well. So let's have a look at these op amps. Any looks like TE929, and let's see what the datasheet says. And I've just noticed, by the way, that this one is different from the others. Okay. Oh, okay. I wasn't reading that right. I've got it under the microscope now, so we can see C4558 is the part number. 4558 is a fairly common dual op amp using audio. Often you'll find BA4558, for example. So the positive and negative supply rail for these is going to be on pin 4 and 8. We can have a look. So we know this is ground, the junction of the two large capacitors. So anywhere on this pad is ground. We can get onto there. And they're not marked very well. Which end is the positive end of these? But hey, we can just go for the colours. I'm sure we'll find the supply rails. Okay, looks like, yeah, this bottom one, I can see that this is pin 8 and this is pin 4. The other ones are harder to see, but it would suggest this is 4 and this is 8. Okay, we'll check the main voltage rails first again after I've soldered the capacitors. So we have plus 37, minus 37, and then on these op amps, what do we have? Well, plus 0.5 and minus 15. So the positive supply rail to these op amps is missing. That will come from these. So these are the voltage regulators we see here. In fact, this one, somebody's been getting warm here, we can see. So this one has the center pin connected to ground. This will be the positive regulator. Okay. This will be the negative because this has a different pin, ground basically. Yeah, this has ground on pin 1. Okay. So if we switch on again and we check on the negative regulator, we have, well, minus 15 on the output, minus 37, of course that's where it's coming from, and on the positive one, half a volt on the output and only 2 volts on the input. So that input is not connected directly to the plus 37 because we know the plus 37 is there. What's this down here? Well, a bridge rectifier and some resistors. Okay. Bridge rectifier must be working because we have the plus and minus 37. I'll bet these resistors are connected from the plus and minus 37 into these regulators. Okay. The first question, do we have a short on the plus 15 volts to ground? Because that's one good reason why we would only have half a volt there, and also one good reason why there's only 2 volts coming in. I would suspect the resistor is possibly open circuit, and that might just be because there's a short on the output. So here is the output from the plus 15. I'm on resistance range to ground. Yes, there's a short or near to a short compared to the negative, about, yeah, very high. Okay. It looks like anyway that there's a resistor there and a resistor there. We can see the tops of them behind the bridge rectifier. And I'm guessing one is feeding from the 37 volts into the positive regulator and one from the minus 37 to the negative, and you expect them to be the same value and fairly low. So on the minus, we have, yeah, 200 ohms, and on the plus, the same. So that suggests the resistor is just getting hot because something is drawing too much current from the positive 15. Okay, 18 meg on the input, very low on the output. So we have a near short circuit on the output of this regulator. Okay, where is it? Well, that positive supply is going to go to all of these. It may go elsewhere, and there may be capacitors. In fact, there will be capacitors on that rail as well. But we can't eliminate these, I would say, because it would appear that the plus and minus 15 don't go to these chips. These are on the high voltage plus and minus 37. I'm certain enough of that, okay? Otherwise, why have the plus and minus 37? Yeah, if it doesn't go to there, it's useless. Yeah, so I'm certain. Right, let's get the thermal camera. Okay, we'll try without the macro lens first, just to get an overview. Let's see what we have. Okay, switch on. Well, we can see this getting hot. This is where those resistors are. But I don't see anything else. Maybe the problem is with the voltage regulator itself. I mean, if there's enough current passing through the resistors to get them hot, then there's going to be enough current going through these little op amps or wherever it's going. Yeah, possible the regulator's got short to ground. I mean, a bit strange, but who knows? Let's see. So I'll just have the macro lens on, have a closer look just to be sure what we can see. So here are our op amps. They all look cold. And this area is hot. I think I see enough then to suggest I remove the voltage regulator and see how that reads. And to do that, I think I'll have to remove the bridge rectifier first, because there's a lot of glue again in this area. So here's the bridge rectifier. This is the glue. These are the two resistors, but the resistors read the same as each other, so I probably don't really need to get to them particularly. We can probably see the value as well, at least of this one. Yeah, very hard to read down there, to be honest. Okay, it looks like it's brown, grey, brown, which is 180, which is basically what I was reading. The other one, yeah, hard to say, guys. Okay, let's get the voltage regulator out. So the one that's on the positive is nearest the end. That's this one. Okay, and I'll do it whichever way seems easiest. Yeah, here's our voltage regulator then, fixed 15 volt positive regulator, 7815. These don't normally fail in the way that this appears to have done, so I'm a bit, or rather quite a lot suspicious it isn't the regulator. We'll find out right now. Okay. Well, that reads high to ground. That reads 15k to ground. Not sure what one of those would read. I'm sure I have some. What's on the board? Do we still have this near short? So yeah, we do. Yeah, I didn't think it would be that. Okay, so we need to figure out where that short is, and the thermal camera wasn't really helping. We can try putting 15 volts into here at a higher current from my bench supply, and then see if something warms up. Or the other option would be to put 15 volts and then use the millivolt or microvolt meter and measure on each of these op amps and effectively try to figure out which is nearest to the short, by which has the lowest voltage across it. I think I'll try, yeah, let's connect my bench supply to here and set a current limit, 1 amp or something, and let's see if that shows anything getting warm. One good reason I am inclined to inject some current here is because this is not exactly a short. We can see that. This is about 3 ohms, okay? If it was like 0, then we could say, and be quite correct, that if we inject current, the current will flow, but where the short is, if it's a dead short, the short has a resistance basically of 0, so there's no voltage drop across the short, yeah, because the resistance is 0. So although current's flowing through it with practically no voltage across the short, it can't get hot. That's clearly not the case here. We have a best part of 3 ohms. So injecting current, I think, will tell us here. And probably didn't help before because so much voltage was being dropped across the resistor. Yeah, there wasn't hardly any voltage across the short. And again, if there's no voltage across the short, you don't really see any heat generated, no wattage, even though current's flowing. Right, let's connect my bench supply to here. We're ready to go. I've set my power supply to 1 amp current limit. I'm just going to connect it now. It's drawing 1 amp. Okay. Is anything getting hot? Oh. Yes. Something is getting hot. There. Let's put the macro lens on and see what that is. Okay. Once again, power on. And that is one of the op amps. Can you see it there? Clearly. Okay. Yeah, I have my finger over it. It's this one. We can just put the point on the screen. Let's go again. Okay. Yeah, 78, 100 odd degrees, okay? So, not a capacitor on this one, but an op amp, and it's that one. This one here, right next to my finger. Okay. So you could see when the power was coming in via the 200 ohm or thereabouts resistor, all the wattage was being dissipated there. The voltage here was like 0.5 of a volt by the time it got as far as here. So that's why that didn't even warm up at all. Yeah. Hope that's interesting. Maybe you learned something there. Okay, so let's unsolder that. And then I'd just like to check to see if there's any shorts on the outputs of it. Yeah, I mean, why did it go? What's caused it to do that? Well, let's see. Okay, we can see it came off nice and cleanly. It's obvious that these 2 pads are connected to each other. You can see there. So this is one of the outputs going back to one of the inputs, just like a feedback. You can see the same thing there, okay, on that one. So that's fine, no problem. Let's check now the resistances on this. So ground to where the 2 ohms was. It's now 70 ohms. That's still, I think, a bit on the low side, to be honest, but that's what we have. The reason I think that's a bit low is because we have 200 ohms feeding into the regulator, which most of the voltage you would think would still appear across that resistor. Just looking at the other one, 30k, 30k. So I think we still have something else on here that is too low resistance. Could be wrong, but if we have a 200 ohm on the resistor on the input into here, I'd expect the output to be higher resistance to ground than that. Okay, let's try again with the thermal camera. And once again, without the macro lens, it's still drawing 1 amp. We now have 1.4 volts. We have something else here. That's another one of these op amps. That's 2 of them then that appear to be faulty. The other ones look okay. Well, let's remove that one as well. Still 70 odd ohms. You know, I think probably all these op amps are faulty. And what's happening is, as I remove one, the voltage from the supply is going up a little bit, and just the next one is lighting up. Let's have a look. So, what voltage does the bench supply give me now? I'm sorry, I didn't show you this before because I didn't think it was relevant. So it was about 0.4, 0.5 of a volt. After I removed the first op amp, it went up to about 1.7. What do we have now? 1.4. Maybe that's what it was actually before, about the same. Let's see then. What does the camera tell us now? Power on. Something here. Something just there. Oh, I think it is. The capacitors looks like it's in between. Okay. In between the two op amps is actually removed. That's just me not seeing exactly what it was. Not a problem. It's very interesting though that the resistance changed a lot from about 3 ohms to about 70 when I removed that first op amp. Now, which one of these capacitors? Well, what I suggest I try and do is see if I can read 70 ohms across any of them. So, once again, across the short. Oh, it's down to 11 now. It's changed again, yeah. You saw that was like 70 before. That's the 11. Right, we're looking for 11 ohms. Somewhere here. 11. 11. High. High. Yeah. $11. 11. They're all going to read 11 because they're in parallel. Okay. Looks like we have a pair for each op amp on the negative side and a pair for each op amp on the positive side. Okay. That makes sense because this is the negative input voltage and this is the positive voltage supply. Yeah. It was getting hot here, so I'm going to say one of these two. I think we just remove them. Let's have a look. Save any more messing about. Okay, I've cleaned this up now so we can just check again. You can see now these are in parallel and the track just runs up to the next one and down to the next one and so on. And we can also see that this does go to the positive supply of that op amp. It's reading 800k now. What's this side read, the negative side? Lower. There's a capacitor charging somewhere. Okay. I think the thing to do is to stick the voltage back on again and see if the 15 volt plus comes up now. So again with the power supply, and now we have 15 volts. Yeah. 50 milliamps. That's fine. So it's now okay. What value is this capacitor? Well, it's not going to be critical. It's going to be the same value as that one, you could say, and that one. I'm going to guess, and because it's in parallel with these, that these are probably 100 nanofarads, and these are probably something like 10 microfarads. That would make some sense. I mean, we can try with the capacitance meter to see if we can read them. But actually, no, I won't even bother to do that because we know they're in parallel. Yeah, They're all in parallel with each other. So that wouldn't help us. I'm going to put a 10 microfarads in here. I've fitted the op amps back on again. I've replaced the capacitor. Let's try once more with the bench power supply and make sure we actually do get the full voltage. And if we do, we'll put the regulator back on and we'll see if this thing still farts. Okay. And here is my power supply. What do we have? 15 volts, 50 milliamps. Okay. Let's put the regulator back in now. Okay. Plus 37, minus 37, plus 15, minus 15. That looks a lot better. Let's see if it still farts then. Although I suspect the flatulence is over. Yeah. So it's working. Let's try the volume control. Well, actually, that works quite well. Yeah. Okay, well, it did work rather well with the volume control until one of the wires fell off, okay? But it actually worked quite well. So what I need to do now is to order some of the correct type potentiometers. Hopefully I'll get the A, but if not, I shall put the B in there. We can see this is working. These ones are not exactly the same, but I think they will fit. The only real difference with these is the mounting tabs come out in a different direction, but I think I can probably solder some thick bits of wire down here to the board to mount it. I'm pretty sure the contacts will fit. These are A type 20K, so that's correct, and they also have the mounting thread as well. So from what I can see, they're probably the best bet, to be quite honest. Okay, so hope you enjoyed that. A little bit of a journey, that one, but we definitely got there. Okay, thanks for watching, and I'll see you all soon on Learning Electronics Repair. Ciao for now, guys.